In this video, we're going to take a look at a couple more examples involving linear models. What makes these a little bit trickier than our other examples is that change d from one unit to the next is not given to us directly. It's something we're going to have to read through the problem and then calculate for ourselves before we can come up with our formula. Right, this first problem involves depreciation. So the change is now a negative change instead of a growing change. But the key is it's a linear change, the same amount of change every, in this case, year. So our truck starts at $32,000. It's depreciating, which you're going to calculate linearly. And at 3 years, it's worth $24,500. So our first task is to come up with the explicit formula. Then we're going to use that to predict the when the value will be 5,000. Well, what is the change? They didn't tell me directly. I know what it went from and to, and I know how long it took, so I'm going to use that information. So the change in those 3 years is 24,500 minus the original 32,000, a negative 7,500. So I did it that way. When you start with the current minus the original, the answer is going to have the sign telling you if it's gone up or gone down. So in this case, I know it is definitely going down. And the change per year, since it was over a period of 3 years, would be minus 2,500 per year. That will help me calculate or come up with my explicit formula, which is the original plus the change times n. So 32,000 minus 2,500 n. Now, if you went and you just took the difference in those two truck values and divided by 3 and said that's 2,500 a year, you would just have to remember in your head that because I'm depreciating or losing value, I need to make sure that's a minus sign there. Okay, so that's important. Now we're going to use that to predict when the value is just $5,000. So they're not telling me n, I'm finding n. I'm going to put this 5,000 in for the piece of n. So using a little bit of algebra here, I'm going to actually swap and add the 2,500 n to both sides and subtract the 5,000. Then I'm going to do my division and I come up with 10.8. So in almost 11 years, this truck is just going to be worth $5,000. Okay, now this one is very similar, except it's growing. Okay, we're increasing in value from one to the next, and it's in months. Other than that, it's pretty much the same problem as the last one. So if that last example made sense to you, why don't you hit pause and see how far you could get in setting this one up. Okay. So if you worked it out, let's check your answers. If you're not sure and you're just following along, let's go through it. The first thing, just like before, is we need to figure out what is that change per month. Well, it said 4 months ago there were 130. Now, 4 months later, there are 146. So the change is 146 minus 130, or 16. It says 4 months, so I'm going to divide that by 4 to get 4 per month, and it is a positive because they're growing. We're going to use that to come up with our explicit formula. So it's the original 130 plus the change times n, so plus 4n. So piece of n equals 130 plus 4n. Now we're going to use that to predict how many months from now will we have 200 lights. So again, they're giving me the answer piece of n, and we are finding the n. So plugging in the 200 for the piece of n, we'll subtract 130 from both sides, we'll divide by 4, and come up with 17.5. So about a year and a half, that's 18 months, right? About a year and a half from now, we will have 200 streetlights in this little town. Let me know if you have any questions.